With problem 31, we also have a derivative that can be found in different ways. Probably the easiest way is to simply multiply this out and then use the power rule. So before we try to find the derivative h prime of s, we'll multiply out s cubed minus 2 quantity squared. And the way you do that is you square the first term, so s to the third squared is s to the sixth. Then we multiply the two, negative 2s cubed, and double it, so that's negative 4s cubed. And finally, square the second term, which is negative 2 squared is positive 4. And so to find this derivative, it's pretty straightforward. It's just 6s to the fifth minus 12s squared. And again, if we wanted to factor it so that we could find all the places where this derivative will be 0, first of all, the answer that we're looking for, that's sufficient right there. But we'll continue to factor. We have a greatest common denominator of 6s squared, a greatest common factor, I should say, of 6s squared, leaving s cubed minus 2. And we can see that that function, or that derivative, will have two zeros, when s is equal to 0 and when s is equal to the cube root of 2. So that's one way that we can find this derivative. The second way to find the derivative would be to use the product rule. Now the product rule is not going to be as simple as this, but we want to learn how to practice the product rule. So if h of s is equal to s cubed minus 2 times s cubed minus 2, now we have a product of two factors, and we can apply the product rule. The product rule is the first times the derivative of the second plus the second times the derivative of the first. So the derivative of h prime of s, is the first times the derivative of the second, and the derivative of the second would be 3s squared. Plus, with the product rule it's a plus, the second, which is the same as the first, so that's s cubed minus 2 times the derivative of the first. First times the derivative of the second plus the second times the derivative of the first, but they're both going to be the same since they are the same function. And since they are the same, actually we just have 2 times that. So that's 2 times, you add 1 to the other and you get 2, s cubed minus 2's times 3s squared. And if we just applied the 2 to the 3s squared, which would be a simple adjustment there, we'll get 6s squared times s cubed minus 2. And so we get the same exact derivative whether we multiplied out and did the power rule or we use the product rule to find the derivative. Okay, we'll continue with number 33. We'll scroll down here. Okay, number 33, we have f of x is 2 minus 1 over x divided by x minus 3. So we sort of have a complex fraction here. We could simplify by multiplying top and bottom by the least common multiple of the denominator, of the numerator rather. Least common denominator of the numerator would be x. So if I multiply top and bottom by x, I get 2x minus 1 over x squared minus 3x. So now we have a simple fraction and we'll use the quotient rule. The denominator does factor, but it doesn't help us cancel anything out. So f prime of x is the denominator times the derivative of the numerator, is 2, minus the numerator times the derivative of the denominator, which is 2x minus 3, all over the denominator squared, x squared minus 3x squared. Multiply out the numerator, 2x squared minus 6x, minus, so that's 4x squared minus 8x plus 3. Still over x squared minus 3x quantity squared. Simplifying the numerator, I have negative 2x squared plus 2x minus 3, again over x squared minus 3x squared. And I don't see that factoring any further, so it's fine to leave that answer as it is there. And once again, that's an example of the quotient rule.